In today's video, we're going to talk about magnetic fields, how they're created, Earth specifically, and how it shows evidence that we may be on the verge of a magnetic pole reversal. The technical name for a magnetic field is a magnetosphere, and two things are required for a planet to have a magnetic field or a magnetosphere, and that is fluid motion inside the core, and also that fluid motion must be of a metal of some sort. So in Earth's case, or the inner planets, that metal of choice is typically iron, and that iron core has to be churning and moving in a fluid form to generate a magnetosphere and a magnetic field. On Earth, we're able to get a record of Earth's past magnetic fields by looking at a location on Earth called the Mid-Atlantic Ridge. It's a spot in the middle of the Atlantic Ocean, hence Mid-Atlantic, where new Earth is bubbling up from the mantle and hardening on the surface to create new crust. So you have liquid rock bubbling up and then hardening. And let's talk about how that shows a record of the magnetic field in the past. The liquid rock emerges from the magnetic field, and the first thing to condense or to solidify out of that liquid rock are the metal fragments in it. And the metal fragments come out and are able to move freely in the liquid rock so they can orient themselves with the magnetic field. A little bit like the compasses in the picture here are orienting themselves to show the magnetic field of that bar magnet. The metal fragments in a rock can show and get a record of what the magnetic field was doing. And then the rock cools and the rock solidifies, and it locks in the record of the magnetic field at the time. So we can now look back at the Mid-Atlantic Ridge and work your way out and see the history of Earth's magnetic field over up to 150 million years in the past. So here's a graphic showing that process. And what they've noticed is that the magnetic field, magnetic poles, have reversed in the past. They have flip-flopped over the years. This is a diagram showing the last 5 million years of magnetic pole reversals. And you see all the reversals are when the color changes from dark to light. In recent history, the magnetic pole hasn't flipped in 780,000 years. If you look at the overall 150 million years, the average is about 100,000 years between magnetic pole reversals. So if it's been 780,000 years since our last one, we're a little bit overdue compared to averages. The magnetic pole of the Earth is also monitored over the years. Every so often, expeditions are made to the magnetic north, and that is found. And you can see in this diagram that magnetic north does fluctuate. It's not always in the same location. And in recent years, there's been dramatic swings in where the magnetic north is located. Computer models and simulations show us that during magnetic reversals, poles become tangled up, and they show up in random locations as there's a tug of war between the north and the south poles until eventually stabilizing into the flipped location. So in summary, our evidence that suggests that we are on the verge of a magnetic pole reversal is that A, we haven't had it in a while. We haven't had a pole reversal in 780,000 years, when the average is about 100,000 years between reversals. The second piece of evidence is that the magnetic north is moving quite dramatically in recent years. It's not as stable in its location. And finally, the third piece of evidence that suggests that we are on the verge of a magnetic pole reversal is that we're seeing random poles popping up all over the globe. And you can actually sail to the South Pacific Ocean, and your compass will tell you that you are on the North Pole, when clearly you are in the Southern Hemisphere and nowhere near a pole. So these three pieces of evidence suggest that we are nearing a potential magnetic pole reversal. What that means for life on Earth: it should not cause too many problems, but may weaken the magnetic field for a period of time while the magnetic pole flips.